Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic One. In this video, I will be providing an overview of a powerful tool that adds a lot of capabilities to a pen tester and security enthusiast toolkit called Feroxbuster. I will provide an overview of Feroxbuster, its practical applications, key features, best practices, and how to get started with the tool. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. In cybersecurity, the landscape is always evolving. The need for robust tools to assess and enhance the security of web applications is growing. Feroxbuster is a powerful tool developed by Ben Epi Risher that is a versatile and efficient web fuzzing tool designed to discover hidden files, directories, and potential vulnerabilities within web applications. Feroxbuster is written in Rust and was first released in October 2020. Per the creator, it was named Ferox, short for ferric oxide, another word for rust, because the name Rustbuster was already taken. Feroxbuster is a web fuzzer that leverages forced browsing and dictionary-based attacks to uncover hidden paths and files that may not be referenced by the web application. It excels in identifying potential attack vectors, misconfigurations, and sensitive information that might be unintentionally exposed. A brief and general explanation of what a web fuzzer does is once it has been configured with the necessary information such as target URL, word list, and various configuration options like recursion depth, concurrency, scan limit, verbosity, etc., a scan can be initiated. The web fuzzer will then append each word list entry to the target URL specified, forming various potential directory paths. An HTTP request is sent for each path to see if the web server responds. Depending on the web server response will dictate what is detected by the web fuzzer. The web fuzzer determines what paths are found based on the response codes received by the web server, such as 200 OK, 301 redirect, 403 forbidden, etc. Based on the return responses, a 200 OK may indicate that a path exists and it may contain hidden files, admin interface, or backup data. As an example, a redirect may lead to hidden content or valuable access points. A forbidden path, when correlated with other gathered information, may indicate hidden resources. There are several practical applications that Feroxbuster could be used for to assist in day-to-day security operations, although some use cases may be a better fit than others. Security assessment and penetration testing. Feroxbuster is a valuable tool for security professionals, including penetration testers, enabling them to identify potential vulnerabilities and sensitive information that may be inadvertently exposed on web servers. Web application development. Developers can utilize Feroxbuster to identify potential misconfigurations or unintended exposure of resources during the development phase, ensuring a more secure web application. Digital forensics and incident response. While not purposely built for DFIR, in certain cases, Feroxbuster may aid in uncovering hidden files or directories that may contain evidence of malicious activity or data breaches. Let's talk about some key features of Feroxbuster. Number one is fast and lightweight. Feroxbuster is known for its speed and efficiency. It can perform rapid scans without causing excessive load on the target server. This is due to Feroxbuster being written in Rust, a high-level programming language known for its performance and memory efficiency. This translates into rapid scanning speeds and minimal resource utilization. Number two, customizable word lists. Feroxbuster supports a wide range of word lists, including predefined ones and custom word lists tailored to specific targets. You can tailor a word list to their specific needs, incorporating domain-specific terms or industry-specific terms to ensure a comprehensive scan. Number three, recursiveness. Feroxbuster can recursively scan target directories, traversing through multiple layers of subdirectories to uncover hidden content effectively. This feature ensures thorough exploration of the web server's structure. Number four, concurrency and multi-threading. Feroxbuster is designed to take advantage of concurrency and multi-threading, allowing you to optimize the scan and increase the speed of the discovery process. This feature is particularly beneficial when dealing with large-scale applications. Number five, HTTP verb support. Feroxbuster is not just limited to GET requests. The tool supports various HTTP verbs, enabling users to interact with web servers using methods like GET, POST, PUT, DELETE, etc. This flexibility ensures that Feroxbuster can adapt to different web application architectures. Last but not least, number six, robust reporting. Feroxbuster provides various output options, including plain text, JSON, and CSV formats, facilitating easy parsing and analysis of discovered content. Feroxbuster generates detailed reports that provides a clear overview of the scan results. This includes information on discovered paths, response codes, and potentially sensitive data. Best practices refers to recommended methods and guidelines for using Feroxbuster in a way that can maximize its effectiveness, minimize potential risks, and aligns with ethical considerations in the field of web app security testing. While this is not an exhaustive list of best practices, these are some items that may help in using Feroxbuster efficiently. Number 1. Request throttling. While Feroxbuster is designed for speed, it's important to throttle requests to avoid overwhelming the target host with excessive numbers of requests. Concurrency settings should be adjusted to find the right balance to ensure a thorough scan without causing disruption to the target environment. Number 2. Word list optimization. Crafting an effective word list is crucial for a successful scan. Security professionals should tailor their word lists to include keywords relevant to the target industry or application. Number 3. Applying updates regularly. Feroxbuster is actively maintained and updated regularly every couple of months on average. Now that I've gone through some of Feroxbuster's capabilities, I'll cover how to get started with the tool. Feroxbuster is fairly straightforward to install. It can be installed on various operating systems including Linux, Mac OS, and Windows. Installation instructions and usage guidelines are readily available on the project's GitHub repository. There are several different methods to install Feroxbuster, all depending on your specific requirements. The tool provides a range of options and flags that allow users to control the scan depth, specify word lists, and configure other parameters. As I noted earlier, there are several options for installing Feroxbuster. For the purpose of this demo, I will only be focusing on Kali. To install Feroxbuster on Kali, I would just run the following command shown in the documentation. Feroxbuster can also be downloaded directly from GitHub or using the git command. You can even grab the binary URL from the releases page and use curl or wget to download. Depending on your installation method, I definitely recommend checking out the GitHub page. Feroxbuster's configuration file is named ferox-config with the extension of .toml located in the /etc/feroxbuster folder. It allows you to customize the tool to your preferences. Once the default values are established, any specifications outlined in the ferox-config file takes precedence, superseding the built-in defaults. Users can define various parameters including but not limited to parallel, scan limit, and rate limit. You can also define your customized word list in the configuration file. And there are specific scan options like max depth and forced recursion, providing granular level of control over the tool's execution. For a more detailed explanation of the options, I recommend going to the Feroxbuster's GitHub repository page. I covered briefly the configuration options available in Feroxbuster, as well as how to install it. I'll go to the CLI and cover some common commands that can be used to scan your target. I will go over the analysis of the results at the end of the demo. To run a basic scan, I just ran the following command shown in the CLI. In instances where there may be a custom web app that needs to be tested, a more customized word list may need to be tailored for the web app. I can use the following command shown in the CLI to use my word list. If I want to speed up my scans, I can increase the number of threads used. I can set them using the following command shown in the CLI. By default, Feroxbuster sets it to 50. Feroxbuster allows you to modify your user agent. You can run the following command shown in the CLI. As can be seen in the output, user agent now shows the user agent string I selected. This is helpful for cases where you want to disguise your scanning activity to appear more legitimate, mimic different browsers during web app testing, bypassing restrictions or WAFs. There are several resources available online to provide a list of user agent strings for a variety of web browsers. Feroxbuster also has a random agent switch you can set that uses the user agents from the Feroxbuster documentation shown on the screen. The verbose switch, as shown in the CLI, provides details in the output of the scan. This can be seen by the black WRN text highlighted in red on the left side of the output. The last option I want to show is the help menu. Running the following command shown in the CLI provides detailed information on features, options, and usage. It's the best place to look to understand the basic syntax for running Feroxbuster. The last thing I want to cover in this demo is analyzing the output generated by Feroxbuster. Analyzing the output is a crucial step in understanding the findings and drawing actionable insights on the security posture of the web app being tested. Upon launching the scan, reviewing the top of the output, Feroxbuster displays current default settings such as the target URL, number of threads, default word list, user agent, and HTTP method used as an example. As the scan runs, you will see output similar to what's shown on the screen. The output shows the response code, HTTP method, the number of lines, words, and characters in a response, and the URL requested. As the scan progresses, you can see the status. The output shows an overall progress bar and directory scan progress bar. It also shows the total time of the scan, requests sent, and expected requests from Feroxbuster. It provides an estimated time of completion, directories found, and any errors encountered during the scan. For a more detailed explanation, I would recommend reviewing the Feroxbuster documentation page located on Feroxbuster's GitHub repository. Feroxbuster can be a powerful tool in a security professional's toolkit. Its speed, flexibility, efficiency, customizability, and robust reporting make it a valuable asset in the continuous effort to enhance cybersecurity. In the demo, I'll walk through installing Feroxbuster, configuring the toml file, and running some scans. Thank you for tuning in to this overview of Feroxbuster. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave me a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic One, signing off.